From James Long, what qualities do you need to be an astronaut?
You know, the math and science.
Yeah,
and
education.
And
yeah,
your education.
You have to have a technical
strong
degree
right.
with either an advanced technical degree or a bachelor's degree with an equal amount of hardcore professional experience.
And we have military people. We have lots of. It's a wide range of people as far as to be qualified. But I think the one thing that is sometimes hard to explain is that it's not just the best and smartest people that you pick.
It's we're
people
examples of that, right?
Well, Don's got it all, but in my case, obviously, there are a lot of people that are applied. There are people I went to grad school with. There are professors that I know, like at places that I studied, like at MIT, who apply a heck of a lot smarter than I am. Just the way
they didn't make it.
They didn't make it. I think, and it's not because that there was anything wrong there. It's just sometimes
you've heard maybe.
I actually don't know why those guys didn't get picked. But I said one thing you do look for that's not necessarily on paper is being able to get along and work as a team player.
True.
Someone you'd want to be around.
That's true, because you're going to be
I'm
around with them for a long period of time,
right, but I think
in a small space.
And that's what I think is being a good team player, being a guy you could trust your life with. I think is the sort of thing is a good quality for an astronaut to have, and that's where you try to see that more in the interview part of the process than what you see on paper.
Yeah. Another thing is you need to sort of be a jack of all trades, because the crew size is small, and you can't have a dedicated science bio guy that can only do science bio, or a dedicated cook, or a dedicated machinist or plumber or whatever. Everybody has to be able to do a little bit of everything with maybe their own little specialty that they can add to the mix. So you have to be well-rounded in terms of your skill sets to be able to function in an environment where you are in the wilderness, you're in the frontier, and you're with a small group of people, and you may need to do surgery, minor surgery on one of your crewmates one day, and then you need to tear apart a flow control valve in a carbon dioxide scrubber the next day, and then you're doing some complicated Marangoni experiment the day after that.
Macaroni experiment?
Marangoni,
sorry.
But you have to be trainable. You have to be willing to be an adult and still be going to school.
But the jack of all trades, I think, I don't know how you feel about it, Don, but it seemed like it became more so important when we got to the long duration stuff, and it's going to be really important for further exploration.
Yeah.
With the shuttle, when you had a crew of 7, people could concentrate on spacewalking, people could concentrate on the landing, people could concentrate on working the robot arm or whatever it might be. You didn't have to do everything. But for a station, now you really have to be able to do everything. You never know what you're going to be called on to do. I lost your attention. This is from Jessica Patrick. Apparently she is a teacher.
Okay.
I gotta like those teachers, because she says, my students.
Oh, that's good.
My students are doing an inquiry on Mars.
Okay.
And want to know what would be the biggest obstacle to humans living there on Mars.
Now, going to Mars and coming back to Earth, the biggest obstacle is probably radiation.
That's what I was going to say.
But living on Mars, you have the effect, the atmosphere, even though it's thin, it's 10 grams per square centimeter shielding.
So the radiation's not as big a deal?
It's not as big a deal. You still
have to worry. It's worse than on Earth, though.
It's worse than on Earth, but it will protect you from a lot of the galactic cosmic rays it takes. So radiation may not be...
It's mainly CO2 on the...
it's mainly CO2. It's the atmosphere.
Right.
Yeah.
All right.
What's the biggest deal on Mars? Probably...
What's the gravity there, 3/8 or something?
3/8. I think it's just making...
It's almost about half the gravity we have here.
I think it's the same thing in terms of what we see on station, and it's keeping the machinery of life support running. Because this stuff is always breaking down. And it's because we're learning how to do it. And when you're going to Mars, it's going to be a long ways to get spare parts. So I think the hardest thing about living and working on Mars is going to be keeping your life support equipment running.
Because you're so far away.
So far away, and this equipment, because it's engineered by human beings, it's not perfect, and any kind of mechanism is going to be breaking down. And maybe after 100 years of living on Mars, we'll have something that's really reliable, but up to then, it's always going to be breaking down, and keeping it running is going to be a big deal.
Okay, this is a good one. All right. I mean, they're all good questions. This is from Laura Austin. And she asks, how fast does the ISS react when the onboard thrusters are fired to avoid space junk? So what happens is when you have to avoid something, you can only go up and down.
Right.
And you can, and this happens. We're getting really good at predicting these things.
We are.
Right. So it's not, you don't worry so much anymore. We haven't had a shelter in place for a couple of years.
Yeah, the last time I think we had one was when I was on orbit.
When you were there with Don,
Yeah,
when
with
Dan was there.
yeah.
Okay, and Dan was the commander at the
Yeah,
time.
yeah,
Okay,
yeah.
so you had to do a shelter in place, but I don't think
Yeah.
we've had one since then. So we're
No, I
getting
don't
pretty
think
good
so.
about finding these things early and then doing an adjustment. Then the crew may not even know about it, right?
No, they always let us know.
Oh,
but they're operated from the ground.
From the ground, okay.
Yeah.
So knowing about it meaning that the ground will take care of it.
Yeah.
Okay, so, but what is it? I think the question was how does the station react to that?
Okay.
What do you
well,
feel
when you fire the rockets on station, you go from 10 to the minus 6 G, which is micro G, to 500 micro G. So the local gravity, so
10 to the
speak,
minus 6, which
yeah,
is little.
Yeah, 10 to the minus 6 to 500 times 10 to the minus 6.
Which is still kind of small.
Yeah, it's still small. So unless you're really paying attention, you barely even notice when we fire the rocket thrusters on station.
Mm-hmm.
You could still float around and stuff. You'll see things on the wall kind of wiggle around a little bit, but in terms of just being there and what you're doing, you hardly notice that you're doing a reboost. And we'll move the altitude of station maybe 10 kilometers, something like that.
So you do your and you do reboosts normally.
Yeah,
So
about
not just to
once every
avoid
3
stuff.
weeks.
So and you don't feel those. Do you know when they're coming? Do they warn you?
Yeah,
or
yeah,
something?
they warn
So
you.
Even for the regular reboosts, not the
yeah,
avoidance.
even a regular reboost. So they'll always
Right.
give us a courtesy call saying, "Hey, we're going to do a reboost tomorrow
And do
morning."
you notice it?
Yeah, yeah.
You do
and,
notice it.
And you have to pay attention.
Pay attention to it.
Yeah.
It's not like on shuttle when we would do if you would
Oh,
fire
yeah,
the
man.
yeah when you do a big
kaboom.
yeah
and-
bonk, yeah hang on hold on to your hats and
yeah,
okay
yeah.
all right.